Okay, everyone, so I have problem number 17 where we have this infinite slab. And we're trying to find the electric field on the infinite slab. And so for this problem, we're actually going to have to do it in two steps because there's going to be an electric field inside the slab and an electric field outside the slab. So for both steps, we are going to be using Gauss's law. And so let's start with the electric field inside the slab. So we want to find Q inside for this slab, and we know that Q inside is equal to rho times the integral of d tau. So we want to find the volume of this pillbox that I have drawn inside. And so if we can look, I drew this pillbox and I'm calling the distance from the x-axis to the edge of the pillbox y. So that means that this segment of the pillbox is just going to be 2y. So we have that equaling to 2y. And now we want to find, so we found the width of this pillbox. Now we want to find the length and the height. But because this is an infinite plane, that means that this guy is also going to be infinite. So it's going to be the length and the height we can't find. So we also know that length times height is just an area. So we can call this 2y times some unknown area, and that would be technically our volume, times rho is equal to our Q inside. Cool. So now we can put this Q inside of our equation for Gauss's law. So we have E dot dA is equal to rho 2ya over epsilon naught. Okay, so now we need to look at the left side of the Gaussian equation. So these squiggly lines represent flux. So we can see that the flux is symmetric. So we just need to our dA is going to be the area of this one side times 2, because there's going to be flux coming out of both sides. So then we can just say 2e, and then we already said earlier that the area of just this side we're just going to call A. So we have 2EA is equal to rho 2YA over epsilon naught. So we can cancel some things out. So E is equal to rho y over epsilon naught in the y hat direction. And this is our flux inside the electric field, or inside the infinite plane slab. So this is when y is less than d. Now for part 2, let's slide this up a little bit. I can. For part 2, whoops. Excuse me. So for part 2, we want to find the flux of the electric field, or not the flux, we want to find the electric field outside of this infinite slab. So we're going to use Gauss's law again, but for this, we're going to actually say that our slab is our Gaussian solid that we're going to use. So we'll start off by finding Q inside again. So like we said earlier, Q inside is equal to rho integral of d tau. So for here, our d tau, the problem tells us that the width of our infinite slab is 2d. And again, we don't know the area of this portion of the slab, so we're just going to call that A. So we can say that Q inside is equal to rho times 2d times a again. So now we can put that back into Gauss's law. It's equal to rho 2dA over epsilon naught. Cool. So now, again, let's look at the left side of this equation. Slide this up a little bit. So same thing as before. There's going to be flux coming out of both of these sides of the Gaussian surface, or our infinite slab. So we can just focus on one side and multiply it by 2. So we can say 2e, and then our dA again is just what we called this. It's just our a. It's just area, the area of this unknown portion of the slab. So a. So then we can then say 2EA is equal to rho 2dA over epsilon naught. We can cancel some things out, and we end up getting, oh, wait, yeah, cool. We end up getting E is equal to rho d over epsilon naught. And this is going to be plus or minus. So now the problem asks us to graph the electric field as a function of y. So starting with, we'll actually just start with the electric field outside of the pillbox. So that's super simple because it's constant. So when y is equal to d, the electric field is constant. So we can draw our little graph. So this will be, say this is d, this is d, say function of y, negative d, cool. So we can say that when y is equal to d, it's just constant. But when we are looking at the electric field inside of the infinite slab, our slope is just, it's E is equal to y times some constant. So our slope is just, oh, nice. It's not supposed to be curved, it's supposed to be straight. But that's, in general, what our graph is supposed to look like.